Hello everyone, welcome back to another video from Winter Forest. If you enjoy this, please like and subscribe for similar video. By the way, you could leave a comment under my channel so see each question. If you like me to explain, I could explain on there. And today's coding challenge is implement tiles prefixed tree. So this is the example and the insert. For this one, actually I don't know tiles, so I searched online. They have a Wikipedia. So if you're going to implement a tile, so first we need to know what is the tile. This work what I found on Wikipedia. And this is the example. Basically, we need to implement a tile is like this one. The root nodes actually have no value. Then you start with your nodes, and once you search, you see the search start you from the root nodes pointer to down. Then you search, you see you have a TO and a TE, TEA. Then you could start with the T and have a TED, then T time. Then you like this one, you have insert A and insert I in and IAM. So basically what how they ask, and if you see they ask you to implement insert search and start with actually I get from here. Here has the code split pseudocode. So basically you need a lot. So you're going to find the lot. This you search, start from the root. If you found, just if you didn't find, just return now. Otherwise, just return. So this you search and this you insert. For each character you push it to a lot. So you definitely need a lot. So you have a dictionary. So we just convert this to our Java language. So let's do it. So in here, and they didn't say have a lot, so I'm going to define my node. I'm going to have each time you see here you insert a character. You're going to build every time you insert, you're going to build this tree. So you have a character, then you have a map. And each character map to a load. Did you see? Each character map to a load. Then we have the value. It is Boolean value. Going to return you found or didn't find. Then I have our load constructor function. Each time you're going to do a load, you put this character in. Is this character equal to character? And also you're going to put this into the hash map. And in here, so my tile always have a one node is called the root. The root node doesn't hold a value. When you new this tile, you're supposed to have this root. This just hold this actually is no value, so it doesn't matter what kind of character put in here. And then you start you insert. Looking here already tell you how to do insert. And in here. So each character, you get a word, you get each character. And if this character not the chart, you just insert it. Let's do it. So once you insert, you start with the root position and insert in and publish each by each. Then you're going to first I know what is my root. I'm going to where to insert the root. The first slot you want insert from the next slot. So you have each char from the word. You turns to a char array. Now you're going to have the temp. You got to load the map. We have this map. Get current character. If you can't not find in your current character, so if you don't find, that means you're going to insert. Then you put this character in, and this is the character mapping character to this load. In here, mapping this character to this load. And if you already inserted before, so just say load equal then equal this temp load. After the loop, then you already inserted this one. Then you set this load equal to true. So equal to true says this already inserted a value. Then you start a search. The search, if you see here, the search always starts from the root. So how I search? I have the root. Start from the root to search. So this what you're going to loop each everybody they found it, then you're going to return true, otherwise you just return false. So you're going to loop every character from this word turns to character array. And then you're going to find, see if I could map, if I could get this character. And if I can't, this is the invalid case. You suppose each character could find. If I can't, then just return false. And otherwise, all of this loop finish, you actually otherwise all of this finish, you didn't return any error, then just return this node.boolean. Return true, actually it's going to be true. And then you're going to search start with. Start with is similar like the search, but only just if you have a start with, then it's fine. So just the load equal to root. Always start with the root. You have the character. Okay, it's called prefix. Change to saying if a load equal to none means you didn't find it. Then you just stop the loop, return false. Otherwise, you loop finish it. Then just return true. This is supposed to do the work. Just let's see if I have a syntax issue. Yes, indeed, 34. Sixty-one. Character C from prefix to character array, string to array. What did I say? CHAR. This is no PREFEX. Oh, prefix. Damn it. It finished. Look like it is satisfied. Just let's go through again. So for this one, we're going to build the tree, and in this tree, we actually use a lot. Every time when you insert one character to each node. Each node have the map and have the boolean. And so if you have a insert for here, if you insert a character and for words, see in character get a character temp equal to non-temp equal to new character map temp equal to. So every time you insert one words, you return this to true. That is why you just return node.bool. Here will be true. So just submit it. Yes, it's working. Thank you. Bye.